Hello, my name is Stephen Boddy, and this is a tutorial describing how to produce 2D and 3D plans for submitting to a planning office using free and open source software. This is not about the detailed technical drawings that an architect will do, for example, interiors of walls and how they're built up. This is about getting the basic planning to allow you to proceed with your project on your home. This is part 1 of 5. It's an introduction and just explaining a few things and doing some groundwork. And then there are an additional 4 parts which will cover each of the individual pieces of software that I've used to produce the images that you can see on screen right now. So a brief warning, while I've given presentations in my work life, I've never created a tutorial for YouTube before, so please forgive the lack of polish. Let's quickly mention architects. Anybody embarking on a project like this is probably going to take on an architect, but they are expensive and you do run into issues as a homeowner with regards to priorities. If the architect has several large projects on the go and you're just a single homeowner with his small house, you're probably going to be lower down his list of priorities. Now, even before I took on an architect, I found a program called Sweet Home 3D, which you can design your house, the layout, check it, etc. So that's the program that I'm working from. But if you have another piece of software that will produce a 3D structure, you could use that just as easily. But this tutorial will focus on Sweet Home 3D and the other programs. So I've already built a full 3D model, and the question is, can I create my own planning documents from this instead of paying in an architect several £1000s to submit them? Well, the purpose of this guide is to document how I got architect style drawings from Sweet Home 3D models. I've made very deliberate stylistic choices. Once you understand how this works, I'm sure the more artistic among you will come up with ideas that I haven't thought of. For my needs, I want to be able to add shadow, texture, or outlining as desired, and I need the ability to do touch-up on the images easily. Some random comments, just to get them out of the way. I will not be showing any images of the original architect's plans for several reasons. You'll just have to trust me when I say that I expect to be able to produce comparable equivalents of everything they created for me, except for minor differences like textures. These tutorials will be a bit stream of conscious. I'm trying to distill a lot of learning and experimentation into something relatively digestible. I can't include every possibility. I can show you the path, but I can't walk it for you. And to follow up on that, this is not a tutorial on how to do every little thing in each program. It's going to assume that you have some basic skills in the program. I can do a follow-up if I've left out vital information due to assumptions on my part, but otherwise you may have to go back to YouTube and find some tutorials if you're just lacking in some skills. It should go without saying that you should have finalized your 3D structure before embarking on this, or you will spend a lot of time repeating your steps. This is a one-way process. The last comment, I'm using metric units. Bushels and cubits might work as well, but I haven't tried it. Your mileage may vary. Here you can see the 3D view of Sweet Home 3D with one of the demo houses loaded. This process that I've created was initially started in response to the Pan3D plugin by Daniels118, one of the users. Their work is brilliant, and the parallel projection stuff he recently added is so close to perfect, but it has a few drawbacks currently, and from what Daniel wrote in the forum, it is not possible to fix them as a plugin. First, the parallel projection does not work when rendering, only in the 3D view. For me, this also makes it almost impossible to get consistently sized, scaled and framed images for different viewpoints. And second, the optional line drawing is all or nothing, and the lines over every triangle is just too visually noisy and would be near impossible to hand edit. For example, if you look here at this sofa, it's mostly black lines, but it's not with the lining turned off. Here you see a lined image from an earlier revision of my house plan that I produced using this process. As you can see, the sofas are very well outlined. Stylistically, the look for the textured images I was going for is best produced by the Blender Workbench renderer, not the Eevee or Cycles renderers. There is no reason this will not work with the other renderers, but it is beyond the scope of this guide. So I just want to touch on graphical projections so that the terminology is well understood and I don't confuse anybody by using an unfamiliar term. So I've borrowed these two images from Wikipedia. Some very good articles on there if you want to search for them, just describing how all this stuff works. But for our purposes, we're interested in the terminology. So we're all familiar with perspective. People probably use parallel and orthographic interchangeably. We have plans and elevations, which we're all familiar with from our documents, and then we tend to think of isometric, but there's actually a couple of other classes, dimetric and trimetric, and those three make up the axonometric projections. And then we have different types of perspective, 1 point, 2 point, and 3 point, depending on how many points of convergence. And then we have some less used things that you're unlikely to ever see in a planning application. So you're unlikely to use them or them. Just to explain the difference between isometric, dimetric, and trimetric, this other image over here. In isometric, all three angles between the axes have the same value, 120 degrees, and the axes are foreshortened by the same amount. So they all become 82% of what the scale would suggest. In dimetric, you end up with two angles that are the same, and a third angle that's different. Two of the axes are foreshortened by the same amount, and then a third is a different amount. And then the final trimetric, all three angles between the axes are different, and all three of the axes have different amounts of foreshortening. Here you can see the documents that my architect produced for me. 10 documents in total, all of them A1 format, with two different scales, 1 to 100 and 1 to 50. When you're talking about 3D plans, trimetrics and perspective views, the scale gets a little sketchy. You can't measure directly off the page and convert it into a scale or into a measurement. For planning purposes in the UK, you will need a minimum of 6 documents, usually. So this will be the existing site, floor plans and elevations, and the proposed site, floor plans and elevations. Now, if you are going to go a bit further, you might add 2D sections. And if you want to go the extra mile, then you would add various types of 3D views and sections. Going back to our slide on graphical projections, I've gone through all of the architect's drawings and categorized each of the individual images on each page. Here I've highlighted those which are actually used. We have plans, elevations, trimetric, and 2 point. Technically the 2 point is actually 3 point, but it's so close to being 2 point, that's what he was aiming for. Natively, Sweet Home 3D supports plan and 3 point perspective. Technically 1 point and 2 point are subsets of 3 point perspective, so you can create these images with Sweet Home 3D, but there is an issue. In order to get the 2 point or 1 point, you have to alter your viewpoint to be square to the axis. The problem here is that those convergence points here, here, and here go through the center of the screen. So if you imagine this is the center, a center line, horizontal line through your screen, and when you render it, it will render that. If you want to include the entire cube, you have to increase the size of your screen, of your render, and then crop it. Obviously this is even worse with the 1 point because this point becomes the center of your screen, and if you want to render, you end up with a very large screen and you're actually only interested in this little bit here. There are two plugins for Sweet Home 3D that can do elevations and trimetrics. One of these is called Side View. The only issue with Side View is that it doesn't give a very readable image. It's looking at this image, it's quite hard to understand what you're actually looking at. The previously mentioned Pan3D tool can also do elevation views as well as the parallel views and the outlining. But for the reasons already mentioned, it's not suitable for the kind of use case I have here. The second program we'll be using is Blender. So what can Blender support natively? Well, it supports pretty much everything. One of the nice things about Blender is it borrows a concept from photography where it allows us to shift the lens. So there's a shift X and a shift Y, which allows us to move where the convergent points are within the screen. This solves the issue of framing for 2-point and 1-point perspective views. I've created a template file which contains a stage which has lots of cameras in standardized views set up all around the stage. They use standard image sizes, standard lens sizes, and this gives you consistent images every time. So the workflow will involve using Sweet Home 3D, from which we will create an object file. That object file will be imported into a template file in Blender which contains our staging and the grease pencil that does the outlining and so on and so forth. From Blender we will export what is called an OpenEXR file. This is a multi-layer image file format. It can handle high bitrate and high dynamic range images. This EXR file can then be imported into Krita, which reads this format natively. So it splits it all up into layers within the Krita interface, and you can edit those layers individually. From Krita, we export straight PNG files, which can then be imported into Inkscape for positioning, layout, any additional edits that you want to make. In Inkscape, we will again use a template file for our drawings that will have all of the normal boilerplate stuff that needs to be on the drawing, like scales and details of the client, etc., etc. From Inkscape, we will eventually produce the final PDF documents that you will be able to submit. That's the end of part one. Part two, which will be following, will be covering Sweet Home 3D in a bit more detail and giving you some recommendations and assistance to improve your model for export for use in this process. I have to say this is quite a bit harder than it seems. All those YouTubers out there have my respect. This is quite difficult. Thank you for listening, and hopefully you'll join me for the later parts. Thank you. Bye.